Hi, hello everyone. This is Ajit Kumar, application engineer reference from UGS Computers. Today we are going to see a hot topic about SolidWorks potential solutions for an agriculture industry. As of everyone knows, SolidWorks has a greatest tool so that it supports most of the different vertical industries like machinery industries, tool and die, power and process, sheet metals, and so on. In that order, today we are going to cover in the agriculture industry. The agenda today we are going to focus on the common challenges that the industrial people face and the solutions that accounts challenges through the SolidWorks to overcome the conversion of 2D to 3D CAD without any difficulty and to reduce the time and as well as manpower by automatic design to avoid the project failures and to improve the quality and reliability. So the first thing stepping into the presentation is the common challenges the industry people face. The first thing is the lack of design communications. In case of any design changes I do, so I have to make a meaningful dimension so that to avoid the reworks and any project failures, so that I don't want to make any manufacturers to get frustrated on the design changes, repeated reworks. So in case of I do, it takes a lot of rework and obviously it's a time consuming process. And when coming to the assembly sections, when assembling the components, it takes me a lot of interferences and collisions between the two components, and obviously it takes me a machine loading time in the very high, and some of the repeated project failures allow me to take the number of prototypes will be more and the cost of the prototypes will be proportional to the number of prototypes. So these all segments will allow me to make a difficult task to meet my project deadlines so that I cannot be enter into the market very faster. Since SolidWorks is a competitive software, so that give emerging solutions to address the most of the challenges. The first thing we are going to see is a bunch of 2D CAD files. Do most of the industries have a bunch of 2D CAD files in their table? So of course most of the answers will be yes. So but here we cannot have any special translations tool so that we can able to convert any 2D CAD files to the 3D without any separate environments. In simple terms, I can able to convert my 2D to 3D in a single environment. And not only that, I can able to apply my real-time materials what I manufacture so that I can able to do in my design stage itself, so that I can check my appropriate weight and mass to focus on the weight reductions or weight additions. And not only that, as I told in the previous slides, to address the meaningful dimensions and to manufacturing sectors, so that I have to create a detailed drawing so that the dimensions should be meaningful, understandable and communicative. So let me see one by one how these orders will be a greatest solutions to address these challenges I shown. So this is my SolidWorks environment, you can see here. So I let you show the first beginning step is to how to convert the 2D files directly without any translations. So I just need only the DWG file or DX file since we have a AutoCAD files. So on the right hand side you can able to see that up to 32 different translators we can able to use in the SolidWorks environment. So without any translators I can able to use even though a third party files like other 3D CAD softwares, and not only the common translator files like IGS, STEP, and even though a DWG or DX files. So here for an example I just want to show you a DWG file. I am just opening this case part so that I would like to convert this 3D Since SolidWorks is a parametric software, what are the changes I do? It will automatically update within the environment so that the design changes happens then and there. So the manufacturer don't want to wait up to the any informations they do, so that I can able to make any updates then and there. The tools we use in the SolidWorks is very much of user friendly. I don't want to stress on the tools I work. So let I focus only on the design, not on the tools. So I just want to convert this 2D entities to the 3D, so that I am just, for an example, I don't need any of this 3D entities, simply deleting this 3D model. To convert into 3D, just as two entities, two views is enough for me to convert directly into 3D. So here I am going to do a reference as this front plane and this as my right side planes. So next I have to make an alignment with reference to these two edges. So automatically it takes me the locations where it has been aligned. So in the front view we can able to see that the alignment has been done automatically, so that the accuracy can be improved. So now the 2D sketch has been completed. Next my job is to instantly move to the 3D environment, so that I have to revolve this component. Since it is a cylindrical component, my only job is to convert this 2D sketches into the 3D. So within a minute you see that I have been converted my 2D sketch entities directly into the 3D. You can find that. So not only that, I can also able to do the more and more works on this model above the model, and these entities that has been created with reference to these sketches, existing sketches. That is the most important term. I can able to convert my 3D models by using only the existing sketches. I don't want to redesign, rework, and I don't want to spend my time by again redesigning the models. So this is one of the major ultimate thing that the SolidWorks has a benefit. So I have to make an extrude cut throughout this model, so that I can convert through a dimensions as well as throughout this model with references to the edges, like that. So within a minute you see that I have been completed a 3D model. So this, as I told, I have to make a material. What material I am going to manufacture? Here I can able to take the what are the materials I manufacture with using of the real-time databases. Up to 250 different kinds of materials that I have been inbuilt, so that we can able to apply the real-time materials. So in case of I am manufacturing this part with the ductile iron, simply clicking apply OK, I can able to make. And in case of any R&D purpose, the research and development process, so we can able to retrieve the properties, real-time properties, and this will be definitely useful for the new product developments. So since I have been applied the ductile iron, we can able to view 3D and intellectually, so that after the manufacture what will be the component and how will be the component I can able to see in my design stage itself, so that I can if I suppose I want to make a weight reductions, I can focus on the weight here. For this kind of component, by using the ductile material, I can check the mass of the component is 736 grams. So this is what I told. So this is the most convenient tool software, so that we can able to do whatever we think, whatever we want to achieve, can able to do without any constraints. So the next thing is to create a drawings. So the drawing is my most powerful thing. I should make a clear-cut communication to avoid the errors and reworks, so that communication should be effective. So by placing the views, I don't want to manually design a view. So by using the view palette, automatically every view has been generated. My only job is to drag and drop wherever I need. For front plane and the right views, so automatically the position it takes me, see the line indicates that automatically aligns the position wherever it needs. And in case of, for an example, I just need a top view. The scaling is the most important thing. We have to focus that I have to maintain that. And in case of suppose I want to make a section view for this, that also I can able to do with different kinds of half sections, full sections, and in case of any auxiliary sections to show the inclined portions, that also I can able to achieve. So everything I have been mentioned here is with a 3D model. With more understandable, I can also convert into the wireframe model, so that the inner lines and the hidden lines can be more concentrated. And the dimensions is the most important and the powerful thing. As I told, the dimensions is very much of easy and convenient method, so that I can place the dimensions wherever I need. So the alignment will be automatically done. So I simply clicking on the edges wherever I need. And not only that, the making of the dimensions with reference to this also easily achieved. I just only the need lines and simply clicking on the edges wherever I need, it takes me the dimensions with automatic reference. So you can find that it automatically takes me the reference with the originate of the 0. So it takes me the best dimensions tools. And not only that, in case of any chain dimensions or the baseline dimensions, that also I can able to achieve very much fast. So for an example, this time I am preferring this edge as my this, and this simply clicking on the edges wherever I need. And not only that, by simply clicking edges on the either sides. So this kind of tools that also I can able to make. The most important thing for the most it will be definitely preferable for the precision components manufacturers. So what are the holes I intended in this? I want to make a tabulated form so that they clear cut understand that it can be very much of easy to manufacture. So by using the whole table that I can be created this much of things that will be automatically generated. With reference to the sketches, I can take those whole tables automatically, so that I don't want to create any things manually. So that since I work in the manual method, it takes me to the error. So to avoid the error, it automatically tabulated where the location and what kind of tools I use and what kind of holes I have been intended. So you can able to focus here the tag, what will be the tag for the easy identification of locations, and the x and y dimensions and the size of the hole I have been included. So these are the things I can easily make a conventional method, so that to overcome the traditional method that I follow to avoid the errors and the reworks. So the every business we do, that will be focusing only on the time, cost and things. So by achieving the bunch of 2D CAD files, the greatest solution, we can able to convert 2D to 3D without any constraints, and just the DWG or DX files is enough for me to convert those files. And this can be definitely useful to avoid the redesigns and convert within the minutes and not in hours. And by applying the real-time material, we can able to check weight or mass within the design set itself, and to avoid the manual detailing, to improve the product quality. The objective of this material database is to improve the product quality by applying the tolerance as per the standard like ASME, ISO, etc. So the next thing we are going to see into the interesting topic, that is the assembly. So what are the product we design? What are the product we manufacture? It should be best fit, form and functions. So we can check any interference or any collisions or any misalignments within the model we manufacture, and also we can able to create the BOMs, which will be definitely useful for the purchase members, so that I don't want to sit and do manually the list of the tables, and this is the quantity I do, this is the thing I have to follow. So these are the things I don't want to make any manually. Simply I can able to click on the table how I created the whole table. Similar to that, I can able to manufacture the things by using the table. It is automatically generated. So for an example, I just want to show you the main assembly thing, that will be how an agriculture people can utilize their designs by using the SolidWorks. So this assembly is nothing but the simple of components I design and come into the assembly environment so that I design. It has 1432 components. So this proves that SolidWorks can handle the large amount of files. So it doesn't mind whatever the file size is and how much of large assembly it is. So it never mind. The SolidWorks will be greatest solution for the large assembly set of files. Actually, this is one of the agriculture model I have shown, and the different configurations can be created so that I can focus wherever I design and to avoid the any interference. So hereby you can see that I am skipping over the configuration so that I can focus only on the designs without any distractions. I don't want any wheel or like that, so that I avoided the unwanted things by using the configuration. So that is one of the major thing I focus, and not only that, to create a new part, so that will be definitely useful for the industrial peoples they create. The only major thing that I have been focused is I can make a new part with respect to the references by the previous sketches. So let us show you an example of how I am taking a reference to these previous sketches. Here for an example, I just want to make an site supporter for this component. So let us show you how I am just making a support within a fraction of minutes. So actually I have to make a reference, since I make a converted every edges of my this face model, and I converted my edges so that I use these edges into the 3D expansions. So within the fraction of seconds I converted these 2D sketches into my 3D. You can find that instantly I can able to move the 3D models, and not only that, I can able to adjust with reference to the scaling I do. And not only that, I can able to apply the different kinds of holes that what I drill, make a drill that with the different kinds of standards like ISO or the ANSI inch or different kinds of standards. And the holes, whatever it may be, either it's a counter bore or countersink or the tapping holes, so whatever it may be, I can apply. So the default database will be automatically retrieved so that I apply with different kinds of standards. For example, I am just going to apply the ANSI metric with using of the counter bores. So this kind of things I can able to do within a minutes. And the sizes, you can able to see the different kinds of sizes that I have taken without any constraints. So my next job is to I just choose what are the hole I apply, and my next job is to place wherever the hole is needed. And in case of any changes I want to do, I can able to change then and there. So that I am just changing, for an example, M14 into 24 I just want to change, and that also I can able to apply. So these are the different kinds of sets that I can control, the different kinds of tools and different kinds of things I can make, that you find any different constraints. So that is the main thing I am just focusing. You can able to do any without any constraints, so that I can make accurate my designs. You see, within a fraction of seconds I just converted my holes, and my next job is to place a 3D nuts and bolts. So that I focus here. So wherever in 2D CAD software we have to make a nuts and bolts, the standard items, we have to individually design, and it takes almost lot of time. But whereas in our SolidWorks 3D CAD, we can able to retrieve a lot of tools within the database itself. I don't want to wait any tools I have to design, and I don't want to wait for the standards I apply. It automatically takes the standard what are the holes we intended. Here you can able to see the hardware libraries like bearings, the ball screws, the keys, bushings, nuts, O-rings, the power transmissions like gears, chain sprockets, so etc. So everything is in the database. Our only job is to choose whatever we need and just drag and drop options. So here for an example, you see I have intended 4 holes. I have to align these holes into this part, so that I can able to create the smart fasteners, so that it automatically takes me what are the standards hole I applied. It places the nuts and bolts wherever I need and with respect to this standard. So that is the main thing and the uniqueness of the SolidWorks. The smart fasteners is a powerful tool, so it automatically selects the standard which I have been intended a hole. So by using the property manager, I can able to control wherever I need. I can make a populate all, so that it takes me the every tools that like the standards. So what are the standards I need with reference to the edges, so like that. And by simply clicking on the faces where I just need, and this is a face I need, and I can choose that. And not only that, the bearings, the bushings as I told, and different kinds of sets, so that I can make is reference to this simply using the design library. So actually I need this place only. I am just simply clicking add. So you can find that within a minute it automatically takes the nuts and bolts So this is the best example, nuts and bolts taken with reference to the holes I intended and the standards I apply. So you find that it automatically chooses the best solutions for the different kinds of standards, the holes I intended, and I apply the M16 holes, so that it automatically takes by these kind of different kinds of holes standards. So the M16 only I applied, so that the M16 only is taken automatically. My only job is to simply click OK. So this is what I told. And the next thing, I want to make the bill of materials. The bill of materials is a major thing, and before entering into that, you can see that the bearings, the chains, and the gears, sprockets, etc. So here I have to make a smart features, smart components. I will show a uniqueness of SolidWorks, the most important thing. So in case of any placing of bearings, you can find that simply I have a bearing here. I am just dragging and placing where I need. So suppose I need in this shaft, I can move to the shaft wherever need, and in case of any here, this is the place, it automatically recesses. That is the ultimate aim of this bearing. So you can find that it automatically recesses the bearing. So if I move to the shaft, you can find that it automatically rearranges the size of the hole with respect to the standard I apply. So by removing the hand of this mouse, I can place the bearings wherever I need, and the matings will be automatically done with respect to the component I choose. And my next thing is to move on to the assembly environment. Let us show you how the SolidWorks assembly files can be handled. So the automatic generation of bill of materials, the purchase list, or the normal this toolbox. So wherever the toolbox I need and how much quantity it need, everything can be generated automatically. So without any time wasting, I am just moving into the 3D assembly environment to the drawing environment. So here I can able to create the different sets of drawings with this kind of assembly setups, so that the bill of materials can be automatically generated by simply clicking on the place where I need and just simply placing the views, like different sets of views. Like you can see that the projected by view, I using the projected view by placing wherever I need the different kinds of views, and in case of any top view or the isometric view. By using the isometric view, I can make an explosion of the 3D views, so that I can make any corrections or the design changes I do, it automatically updates in my drawing, the part as well as in the assembly. So that is called associativity. So that's what I told, the associativity of the components. So here I just want to make a bill of material for this. So simply clicking on the bill of material table, it automatically runs behind the software and generates each and every part and quantity automatically. We don't want to make anything manually, so we can avoid the manual errors, the time and the cost. So it automatically generates a table with respect to the each and every components. So you can find that within a fraction of minutes I have been generated the bill of material with each quantity, each component. I missed nothing. In case of any balloons, I just want to check my each component with reference to the where the component is, so that I want to make a balloon, so that the balloons cannot be done manually. To overcome those challenges, I can make those balloons itself by creating the auto balloons. So automatically the balloons can be generated with respect to the bill of material tables. You can see the each components with reference to the where the location is, everything will be done automatically. You can feel the difference from the manual work to the traditional method to the conventional method. You can feel the difference. So that is the main thing I just like to share. So whenever we do in a traditional method or the manual, so we can feel the difference when comparing to the SolidWorks 3D CAD. And in case of any evaluations, so that I can make the references that I made with reference to the different kinds of components I made, so the everything it automatically generated within the software itself, so that I don't want to wait for any of the design changes as I told. So you can find that each and every items in this part references to the components where it is. In case of any mini sub assemblies also, I can able to create with different kinds of sheets. You can find the below of the screen the different kinds of sheets. I can make the different sub assemblies so that focus only on the respective components. The next thing I just want to go share is the things we can achieve, like avoiding the assembly errors and reworks, and to reducing material wastage, accurate and automatic BOM, and the purchase item list, reduce the number of prototypes. So these are the things I can able to achieve. The main objective of this fit form and function is to avoid the assembly errors and reworks only. So obviously it takes me to the material wastages reductions, and the BOMs and the purchase item list will be definitely very useful for the purchase members, or as well as the documentations will be automatic and accurate. So the next thing we are going to see is the how to evaluate the product and what are the things we can achieve by evaluating the product. Before that, I have to show you the if we face any repeated failures or the maximum load acts, where the failure begins, and how much strong our product will be. So these are the common questions that raise, and of course there will be solutions on the right hand side. You can find that we can achieve the failure at the design stage itself, so that we can able to take any respective actions to avoid those errors and reduce number of prototypes. And of course we can able to know the product life and the design stage itself, so that we can able to recommend the exact variety of our product that we manufacture, so that we can able to satisfy our customers very much more. So let us show you a simulation part that how it will be more helpful. So in this I have been tested and same the agriculture model, so that I have been created. I'm just closing this document, and let us show you a best example of the another plant seeder requirements, so that you find that the different kinds of analysis you can do that with different structural analysis and the different kinds of bolt strength analysis. So these are the things we can able to achieve very much of easy manner. So actually this is one of the plant seeder model you find here with 262 components. So here this model also has different configurations that we can able to do. Here you can find that the different tubings, and so that my input will be these two intersections, so that I can make the transparency, so that I can visually what are the things involved in here. So this is the major benefit of SolidWorks 3D CAD, so that I can able to find 3D. So this is my ultimate model after a manufacture. So this part I told we can able to reduce the number of prototypes and the errors. So this machine has a different configurations with up and down and with the rotary motion, so that I can able to find, so that you can find that the rotation motions, etc. So in this scenario I just want to make a analysis for this component. here what are the analysis we do, we have to focus only on the most loading areas. So in that order I just want to focus here, so that you can find that the component individual environment and the analysis can be done within the software itself. I don't want to go any of the additional software or outside of the software. So the software simulation will be a greater solution for analyze the product and evaluate our product among the customers, so that we have to satisfy by recommendation of exact warranty. And not only that, we can able to do what are the things we do in real time, like the analysis with respect to the fixtures or the force, what are the act and where the force acts. So these are the things we can able to achieve here. And not only that, then as I told, the bolt strength analysis, the weld strength analysis, and in case of any life warranty analysis, so that everything I can able to make. So in this scenario I just want to like a static study of this model by making the fixtures. So there are different kinds of fixtures I can make with real-time scenarios, like fixed geometry, or one end is fixed and another is free able to move, and the roller sliders. So these are the different kinds of fixtures, even though a bearing or the elastic supports. In this time, for an example, I just want to make a fixed geometry, so that I going to fix these cylindrical areas. You can find these are the areas I just want to fix. And not only that, the fixing of areas I have to make an application of force. So those force can be the torque, the pressure, the gravity, or even the temperatures in case of any thermal analysis. So everything we can able to do. So here my force acts upon the surface, so I towards the downward directions, so that I make, and for an example on 10,000 Newton force I am just acting towards the upper surface with respect to the arresting of these two edges. So you can find that I have been applied a force and the geometry has been fixed, and the what material I have been manufactured this part. So as I told in the previous presentation, the material we apply we can able to create on the database, so I can take on the real-time environment. In case of any grey cast iron, for an example, I am making this analysis for a grey cast iron product. So simply choosing everything I need and just simply clicking run, it automatically runs behind the software and the formulas, equations. So everything it will be automatically calculated, so the final result will be shown into the screen. And not only that, we can also able to take a report with respect to the Word documents, so that we can able to share within our customers or the prospects, and we can guarantee ourselves so that our product will be has a lifelong with respect to this much of years or months, and where the first failure begins and the maximum failure area. So these are the things we can able to retrieve by those reports. So in case of any motions, that also I can able to do, like linear motions or the non-linears, or either a dynamic. So this kind of analysis can also be done. And not only that, as I told, the flow analysis, like wind, if my product acts in a wind, how much wind force it requires to move the component, or any failure will occur due to that wind force, and the thermal analysis due to the temperature. So everything I can able to calculate within the SolidWorks environment itself. So the final result of my 10,000 Newton force with arresting these edges is, you can find on the right hand side, you can see the chart. So for better understanding, I will make you the floating values, so that you can find that my maximum stress will be the 2.1 megapascal force. So that this chart will be a greater reference for me. It starts from blue color to the red, makes me that it gradually going to the failure stage. So by understanding of this blue color, wherever the blue color occurs in the model, yes, it is a safe, so that I can manufacture by this much of thickness itself. The red color shows, in case of any red color shows that I have to increase either the thickness or the product dimensions. And by simple terms, you can find that the displacements by clearly understanding that my displacement of this model by understanding this chart, it shows that from the blue color to the red color, as I told, and my maximum displacement will be the 5.41 mm. So you can find that this is what I told. By utilizing this chart, I can understand that my maximum displacement of 10,000 Newton is my 5.41 mm. And not only that, I can able to calculate the factor of safety also. So that is one of the major thing we have to focus while evaluating our product. I can be able to make the factor of safety with respect to the constraints. Within the limitations also I can able to set without any constraints. And the difference wheel strengths and the user difference strengths. So everything I can make without any constraints. So by applying the 10,000 Newton force, by adjusting these edges and my 5.1 mm displacement, my factor of safety will be the 0.72. Of course, this indicates me the failure of my project, because every model, every part, every component we manufacture, it should meet at least one times equal to the load we apply. And most of the industrial people follow 2.5 times of the factor of safety, so that I can make any thickness changes, any dimension changes, or the load decreasements, or the support improvement, I can able to improve my factor of safety. So let me come to the end of the sessions. As I told, we can know the failure at the design stage itself. Obviously, the objective of this SolidWorks simulation is to reduce the number of prototypes and to reduce the product life at my design stage itself. Can able to predict the product life and can recommend the exact warranty of my product I design. So guys, let me move on to the end of the sessions. I just want to summarize my things. I have to cover this much of time, and at last we can eliminate a bunch of 2D CAD files. If suppose there will be a lot of papers in my table, without any limitations, we can turn every 2D CAD files into the 3D, and the material wastages can avoid, so that the assembly errors can be minimized. To communicate effectively, the detailed drawing very much fast and accurate with exact tables like bill of materials or the whole tables I apply and the purchase list. So everything I can generate automatically what are the design I do, so that the avoidance of inventories definitely useful for the purchase departments and also the documentation purposes, and we can able to reduce my reworks. So our rework can be reduced and the productivity can be increased, so that the product of the quality and product of the reliability can be increased, and to reduce the number of prototypes, so that obviously I can reduce my prototype cost. So at end of the hanging, everything I do, everything I just want to achieve, I can definitely meet my project timeline, so that I can reduce my lead time without any constraints. So at last, I would like to say that 85% of the product cost is decided by the 3D design. Thank you.